Hi all, in this video we are going to learn about NoSQL databases. So it will be a quick session and a very short session which will talk about NoSQL databases. Okay, so in this the main objectives that we are going to cover is what is a cap theorem and what do you mean by scaling up, scaling out, the different type of databases, and also what is the difference between SQL databases and NoSQL databases, and what are the different types of NoSQL databases that are available, right? And when you look at the history of databases, you all know that it started early from 1970 by the Court's relational model, right? And relational model has been in the industry for a very long time, and still now also we are using MySQL and PostgreSQL and all those stuff, which is very widely used nowadays as well. So they are like strong versions of SQL, SQL databases or relational databases. But in 2010, in 2010, the the NoSQL term came into the first one which has come is from Berkeley. So it has come into existence, and from there we had a different variety of technological advancements in the field of databases. So when you look at the developer survey, which is just conducted in 2022, you could see that MongoDB is basically one of the non-relational databases which is very widely used, and Redis is also another non-relational databases. So when you look at this particular scores, which how people have actually rated it, so MySQL, PostgreSQL, SQLite, all of them are relational databases, and MongoDB is actually kind of one of the first non-relational databases which has got the highest usage, which has got almost 28.3% of its percentage of the people are basically using MongoDB because of its advantages. And now we need to know like what you meant by a cap theorem. So cap theorem is basically, it's kind of a common theorem. So consistency, availability and partial tolerance is what this cap is all about. So cap theorem is basically it is actually used as a distributed computing system. So whenever, because in non-relational databases we will understand that we are going to again emphasize on the distributed computing system. So consistency is that, like say you have done something and somebody else have changed it, that change has to be consistent across whoever sees that change, right? In the system it has to be updated, in the database that change has to be updated, right? And availability is nothing but all the reads contain like data, so it might not be most recent, right? I mean, like say if I have any copies, recent copies which are available, all those copies has to be available there for my assistance, and that availability has to be there. And partial tolerance is that if any partial network tolerance failure happens, still I should be able to continue my operations which without any delay or any issues, right? So NoSQL engines basically have this capability of horizontal scalability that you will see in a moment, and that basically contributes to this partition tolerance. And yeah, so this is nothing but the cap theorem. So when you look at the cap theorem, each of the databases which are already available in the market has got different type of usages, I mean like different type of capabilities. Say when you look at MySQL and PostgreSQL, they have got kind of a hybrid capabilities like both availability and consistency. But when you look at HBase, it has got both consistency and partition tolerance. And when you look at DynamoDB and Cassandra and all those stuff, it has got availability and partial tolerance. So each of the databases has got its own capabilities, but all those capabilities are related to this cap theorem. So when you look at consistency, all the clients will see the same view of the data even right after an update or delete. So even if any changes happen to the any changes have been done on the data, that changes has to be reflected so that a consistent view is available for all the clients in the data who are using the database, right? And then comes availability. So availability is that all clients can find a replica of the data even if in case of partial node failures. So nodes, that it's all the systems, right? The systems are kind of machines which are there as part of your network, right? They are the nodes. So if any node failures occurs, there will be some availability options. That means the data which is available in one node will be available in some other node as a replica, so that even if any node failures happens, you have the data at your hand. And then comes the final one, which is partitioning. It is nothing but which is very important in case of network failure. So even if there is any partial network failure, the system will continue to work as expected. So that is nothing but the partitioning, right? And then, as I told you, we will see in a moment, like what you meant by scaling up and scaling out. So in any industry or in any organization, there will be a scaling up and there will be a scaling out. That means a vertical and horizontal scaling. So vertical scaling is nothing but if you want to increase your speed of the machines, then you have one single system, but you are actually increasing the number of the racks, right? So you have one single system, but you are actually increasing the number of the racks by putting over it, right? So maybe you are increasing the RAM or CPU or memory to one existing machine. That is nothing but scaling up or the vertical scaling. And then the other thing is called the scaling out, which is mainly useful for the distributed computing scenarios. Say if you want more machines to be added, so that you can actually work from different places or different countries or kind of stuff, then you have to do a scale out, which is nothing but horizontal scaling. So normally the SQL databases, when you look into the concept of SQL databases, you know that the data is basically stored in rows and columns, like say tables, right? So that is basically nothing but the relational nature of the SQL databases, right? And it is basically used for, say, all the tables. I mean, like, say, all the relations basically will have this row and column structure, which is actually followed across. Say if you have a university database, you have students table, you have course table, you have enrollment table, you have teacher table, but everybody will have each of the relation will definitely have rows and columns. So everything basically and in the data which are there in one particular table possess the similar properties. That means that, say, if in the student table I have got student ID, student name, and the student courses, the courses which is enrolled, then the data which is actually going into that particular table, every data, every record will have this kind of, so I will be able to gather the maximum kind of information as the properties which are there in the table, right? And the schema is very strict, so that schema has to be followed. So it could be like, you have 10 different rows and you cannot just leave one row just like that, right? And the other one is asset transactions. We will see about this asset transactions more in detail, are supported and scales well and vertically. That means that SQL databases mainly support vertical scaling. That means that when you are using this relational databases or SQL databases, you will have a faster output, a faster response than, it is not suitable much in a distributed computing architecture, but at the same time it will be very well suited if you need to, the response time from the SQL databases will be less. And then comes the NoSQL databases. So what do you meant by NoSQL databases? Is it like, you're not going to use SQL database? No. So the meaning of this NoSQL database is actually not only SQL. So that means that you have all the capabilities that is actually possessed by SQL database, plus you have something more. So it's like, as you say that you're extraordinary, that means that you're not ordinary, you're even more ordinary than the normal people, right? So it's something like that. So it's not only SQL, so you have something more, right? So the term NoSQL was actually founded by Carl Storsey in 1998, and this is a mechanism basically used for storage and retrieval of data that employs less constrained consistency models than traditional relational databases. I mean, like in traditional databases, you have a very strict schema that has to be followed. But say if you don't want to follow that strict schema, then you can go for not only SQL or NoSQL databases like MongoDB, Firebase, HBase, or Redis. Now comes a little bit more about NoSQL databases, right? So when you look about the records doesn't have to be of the same nature. That means that, say, if you have a data, okay, if you have a data, I'm just taking this one, say you have a say if it is in the case of a relational database, okay, say you have student ID, okay, and you have rows and columns, say you have student ID and you have something like name. So each and every record you see will be basically following the same format, right? But in the case of the NoSQL databases, it is not so. In the case of the NoSQL databases, it is not mandatory that you have to use you have to follow the same structure which you have to be followed. That's not mandatory, right? So no schema requirements to are there too. And yes, it follows a little bit of asset transactions, but not, you don't have to make sure that you're completely following everything as in your relational databases. And consistency can vary. That means that as changes happens, your NoSQL databases will be consistent in course of time. That's all you could say. When you do some immediate changes, that doesn't mean that your database has to be consistent. Yes, but ultimately, eventually, your database will be consistent. That's all you could say. And large volume of rapidly changing data, unstructured, structured, semi-structured, all this different kind of data could be stored in non-relational database. You can have images, you can have text, you can have videos, you can have audio. So all this kind of different type of data could be stored in one database itself. And it is a scale out architecture. So if you require more distributed computing or distributed architecture, then you can basically go for NoSQL databases. So these are the major differences between SQL databases and NoSQL databases. This is just a random row look or differences which you could see. The storage model, so how the data is stored. In SQL, as you all know, that it is stored in rows and columns, and in NoSQL databases, it's basically follow this key value store. Okay, so there are different type of these are the different type of databases which are available in NoSQL. Key value, it could be like key value pairs, it could be document store. I'll tell you, you will get to know about what is document store in the next classes. And graph store and wide column store. So these are all the different type of ways that you could store the data in NoSQL databases. And regarding the properties, basically NoSQL databases has to follow atomicity, consistency, independence, and durability. But in the case of the NoSQL databases, it is base properties which has to be followed, right? So it is base availability, sub-state, and eventual consistency which has to be followed, right? And then comes to the schema. So when you talk about the schema, it is structure and predefined. And I mean, like, if you have this many columns, yes, this many columns, tables, rows, and columns has to be there, right? It is fixed, and you cannot actually change in course of time. But in the case of schema which is used in NoSQL database, it's completely unstructured and dynamic. As and when you have to add more data onto your table, you can keep on adding more data. If you want to delete something, you can delete. So all those flexibilities is basically available for you. And syntax, so it basically follows a SQL syntax itself. And when you look at NoSQL, you will see in the next classes. And complex query, yes, it is SQL can accommodate good amount of complex queries. But in the case of NoSQL databases, yes, it does, but only not that great in dealing with the complex queries as SQL databases. And the hierarchical data, yes, SQL is a bad fit, but in the case of NoSQL databases, it's a good fit. I mean, like the graph data or different kind of hierarchical data, you can actually store all those in NoSQL databases. And then comes the scalability. So it is vertically scalable, and as you know that it is for increasing the speed. So your response time, when you think about the response time in SQL databases, is very less. But in the case of horizontally scalable, or you are mainly concentrating on the load balancing. That means like you are including more number of nodes in the system, so that you can balance the load in a better way. So you are actually making your system more distributed than so there will be some delay, but still it is distributed. And stability, yes, it is SQL databases, as there for long years it is actually more stable, but NoSQL databases might be, when compared to the SQL databases, it's less stable, but it's not bad. So asset properties, as you know, as you have already learned in SQL and relational databases, it's atomic. All operations in the transaction succeed, or every operation is rolled back. That means all your operations which you have done is basically saved, right? And consistent means if databases, if you have any issues, whatever changes which happens to the system is actually updated in the database as such. And isolated transactions do not contend with one another. I mean, like, if there is any access of data moderated by the database, so that the transactions appear to run sequentially, but you know that it's different views which are actually working about. And durability is the results of applying the transactions permanent even in the presence of failure, so it's durable. And base property basically looks like this. So you have basic availability. That means that basic availability is BA, and the database doesn't appears to be appears to work most of the time. So it is not like it's working for some time. So it's like kind of dynamically working. And soft state is that it is write consistent. So stores does not have to be write consistent. That means you have done any changes, that changes doesn't need to be reflected at the same moment, but it will be reflected in course of time, right? So that is nothing but eventual consistency. And soft state, different replicas have to be mutually consistent all the time. So so it is not mandatory that all your data has to be write consistent, nor your different replicas have to be mutually consistent all the time. So that's nothing but soft state. So all these options are basically available for base properties. And when you look at the type of the SQL and NoSQL databases, if you could see, so in the SQL databases, you already know this relational databases and OIL API. I don't know how many of you have actually seen. That is online analytical processing. And the other one is the NoSQL databases. So you have different type of databases available, like key value pairs, column family, and graph. And Neo4j is one example of the graph database. And the document store, which you are going to see, is nothing but your MongoDB. So different type of NoSQL databases are available. So first one is basically the key value pair. So as you all know that it's just key value pairs, and the data is accessed by the strings called key. So the keys has to be unique, right? So the values could be of any format, and it's a simple NoSQL databases. And basically you can do all these basic operations like insertion, fetching, and updation and deletion. And the main applications will be like session management, caching, and web applications, etc. So you have Rayak and Reddish and Berkeley DB, which has actually come as one of the first one of the key value databases. So when you look at it, you will have a key and you have a value associated with, say, city is New York, state is New York, and country USA, kind of, right? So you will have a key value pair which is associated with each of your values. Then comes the column store. So column store is like a column database. So it's a smallest instance of data. So has columns of column families with a key, and there will be large volume of data transfer, which could be done faster way. So Cassandra and HBase, and Cassandra is one of the databases which is very easy and which has been used in the big data scenarios. So all your data will look like column databases, and this is how it will look like. So internally your column database will also again look like key value pairs only. So Eric Long, and these are the columns. So again it looks like nested key value pairs. And then comes document database. So document database is mainly MongoDB and CouchDB and all uses this document databases. So here also we have this key value pairs, but you have more options of and operations with this key value pairs which are available, like key array pairs, nested documents, and it can store semi-structured data. And there is something called collections which is there in the document databases, which is very useful, and again used for web development, mobile development, data handling, content management. All those things are basically possible by using the document databases. So in documents, so basically it is like this. So you have got a document, and if you have a set of document, you could say that it's a collection, right? So your MongoDB database will have multiple collections. Okay, so that is how it basically works. So you will have collections and documents in that. So you will have, this is a collection. So basically whatever comes inside this is a collection, and you can have multiple documents which are there inside. So each document, if you could see that they will be like key value pairs, right? So you can have subarray of collections and all those stuff. So you will learn all those things in detail. Then comes the graph databases. So graph databases also can store a lot of knowledge about the data networks. And in the graph store, you will have each node will be acting as a record in the relational databases, and the edges will have the connections. So that is the one which will actually connect between the nodes, and they are nothing but the relationships. So they're basically used for social analytics or social media, open linked data and all those stuff. So you will have seen the semantic web and reservation systems and such kind of things. You will use that. So Giraffe and Neo4j is basically very famous, and you should all look out to it. So it's a very simple database. It's very easy to learn. So you can easily form all. It's a graph. So it's not a I mean, like it's not a tree, it's a graph, so it can have multiple relations in our forming. So when you look at the DBpedia data, DBpedia is the Wikipedia data. So Wikipedia data and all, you could see that big semantic web data, which is actually formed by using this such kind of graph databases. So now we need to know that, okay, we have good understanding about what is SQL, and we have good understanding about what is NoSQL, but when to use what. Okay, so if you have completely structured data, if you're very clear about what you have to do, then go ahead with your SQL databases, relational databases. But if you have data which is like keep pouring in, like dynamic data, and if your RDBMS model is too restrictive to follow, that means traditional RDB is too restrictive, then go ahead with a more flexible one, which is NoSQL one. And where the base properties are of use, or asset properties are not of a much priority, then you can actually go for NoSQL databases. And scalability is the key, because when you are using this, you can have horizontal scalability. Then when logging data from distributed sources, so whenever distributed computing or distributed architecture comes in picture, then you can think about NoSQL databases. And when flexibility is required in terms of schema design, that I may add each I may add each property later, I may add, so if you are using a relational database, the schema is very rigid, you cannot change it in course of time. So if you want this change to be possible and dynamic changes to be possible in your system, then you should basically go for NoSQL databases, right? And if you want to store about events and temporal data, in such cases, like where you are not you have to deal with different types of data type itself, like the images, I mean, like the videos, the audios, the textual different kind of data types. If you want to deal with, then you have to basically go for NoSQL databases, right? So that's all about it. So we have just seen about what you meant by NoSQL databases, and we have seen about the different type of NoSQL databases available here, and also what is an asset property and base property, which we see in NoSQL databases, right? So that's all about it. So just have a look and be prepared for your classes, and all the best. If you have any doubts, you can always get back to me as always. Thank you so much.